Hello students, today we are going to discuss that application of integration areas. Outsketch of the presentation. Today presentation is objectives, introduction and area under the simple curves and area enclosed by the simple closed curves. Area of the region bounded by the curve and using the line. Another is the area enclosed between that is a two given curves and a summary. This is the outlines of the contents of the today presentation. In this mainly we need to discuss about that is the area under the simple curves and area enclosed by the simple closed curves. Here we have a knowledge, previous knowledge, it is a area we can identify the triangle, rectangle, circle, ellipse, such kind of all the areas we can be identified directly. We have a various methods in the geometrical methods. Now using the integrals we will be identify this is one of the easiest method and techniques for the whichever the we cannot solve under the previous methods we can be use it. This is a finding of the areas under the simple curves and area enclosed by the simple closed curves. And the region is bounded by the curves and the lines such a way it is whenever we have a bounded region with the curve and line, that area how we will be identified by using the integral. And the third last one is the area enclosed between the two given curves. That curves, if we give that it is enclosed between the two given curves, we can identify that is the area. This is the overall observations for the outsketch of presentation. Now objectives of here specific applications of integrals and its areas how we can be identified. Second objective is comes to the area under the simple curves and areas enclosed by the simple closed curves areas how we will be identified by using these methodologies. Area of the region bounded by the given curve and the given lines we will be identified. And area of the region enclosed between the two given curves we can be identified. With these are the objectives of today in this lesson. Now in this introduction part, here elementary geometry methods if we apply that areas, various regular geometrical figures like a triangle, rectangle, squares and circle and trapezium, such all the cases we have a various methods to elementary methods for the geometric methods we can be identify the areas. Now whenever it is not adequate to the finding that is the areas and which is are enclosed by the curves, such moments we have to be apply that integral calculus and evaluate the areas. Now another application is in this unit we learn that it is enclosed by the simple curves so bounded between that is a given line and arcs of the circles and parabolas and ellipse which bounded areas also we can be identify that areas is by using the integrals we can be identified. These are the introductions. Previous knowledge is enhancements is we are learning by using the integration to find the areas. Now first method is first logic is area under the simple curves and area enclosed by the simple closed curve. In this we think of the area under the curve as a sum of the large number of the elementary areas, very thin vertical or horizontal strips. Example, here I will take that it is a vertical strips. If I take that it is a y axis in the figure 1 and figure 2. Here whenever it is a x axis upper will be there, the function is a y equal to f of x is a positive greater than or equal to 0. Whenever the function is a bottom side y equal to f of x in the figure 2, it is called as a y equal to f of x is a less than. Less than means x axis upper or x axis low bottom. Upper is comes to the cases is a one kind of application of integrals and bottom side is another kind of applications. These are called as a simple curves areas identification. Now it is a horizontal means it is a interval if I take into the a to b, for example x equal to a, x equal to b, it is a p to q. That p to q identify if I take the intervals and function is y equal to f of x, that is comes to the horizontal, and whenever it is a y axis width it is a interval based on that if I identify the areas, that is comes to the vertical interval vertical strips. Now, in this region specified by the some values of x between the a and b, it is I am talking about that first figure PQRS, which is a area y equal to f of x be the function s to r, and it is a distance is taking the x equal to a to x equal to b, p to q. Now, it is a total area observation will come to the PQRS. It is a figure 1. In this figure 1 is a region specified by the values between a and b, which is the total area is the capital A, which is a region between the x axis or coordinates x equal to a and x equal to b. That is the figure number 1. Here curve is I am taking f of x is greater than or equal to 0 because of it is a upper side, which is a strips across the region PQRSP. Now, I want to identify the area. Capital A equal to integral a to b into dA. dA that is equal to, what is that? It is integral a to b y dx. Y equal to how much? F of x. So, I will substitute integral a to b f of x dx. This is a identification of simple curve finding area when that function f of x is greater than or equal to 0 into the interval a to b, that capital A equal to area equal to integral a to b into dA. So, that integral a to b f of x into dx. Now, I am going to find out that simple curve area that f of x is less than 0. There also interval is a to b if I take, that is area bounded by the curve. The x axis coordinates are x equal to a and x equal to b, come to the negative outlet. Then since it is take into the consideration of the numerical values of the area, we consider positive value, that is absolute value, integral a to b f of x dx. Area is always positive, so that it is a function only we use f of x is a negative function, but it is integral a to b, it is a bounded area. A is a will you get that integral mod value, you should consider that area, that is in the figure 2. That figure 2, it is a, what is a block area is there, that a to b region, y equal to f of x is less than 0, that is the bottom curve downwards. That area I will identify mod integral a to b f of x dx. Now, sometimes it is a, it may happen the area is a some positive and some negative. Some positive and negative areas, whichever the negative area will be there, that area we should take into the modulus. Whichever the area is a positive will be there, that is a y equal to f of x greater than or equal to 0, that directly you find out the interval between that area, and it is a, we can obtain the total area A equal to mod A1 plus A2. Now, here clearly curves is a figure, it is appears into the up and downs, it is a up means it is a positive function and down means it is a negative function. Function is started to the negative function to positive function. Now, with the interval. Now, coming to the, I want to identify area between that region x equal to a to x equal to b. Now, what happens x axis, the set of the below x axis is if a1 area I should identify and a area you should be identify correspond to the portions lies x axis a to area consideration. Then x axis, then the a is bounded by the curve y equal to f of x. The x axis, the coordinates are x equal to a and x equal to b, gives that a total area capital A equal to modulus of a1 plus a2. a1 is a bottom area and a2 is a top area. Now, here these three are the simple closed curves areas that we will be identify here. Find the area enclosed by the ellipse x square by a square plus y square by b square equal to 1. Now, here this is enclosed by the simple closed curves. Enclosed by the simple closed curves means it is will be go for that is the ellipse. Here whenever we have a distance, there we will be identify the function positive side, function negative side, it is a total, it is a positive side and a negative side of the functions, that areas we can be identify for the identifying the areas of the simple curves. If the enclosed means here enclosed simple closed curve, their case here figure we can see in this one part of the area if we identify, remaining 4 parts here OAB area if we identify, OBA dash and OA dash B dash, OB dash A, it is how many areas? 4 areas are the equal. So 4 times of it is a single area we will identify, that is called as a closed, enclosed by the simple closed curve area of a simple closed curve. Previously simple curves I identified. Now here first example I am taking for that, find the area enclosed by the ellipse x square by a square plus y square by b square equal to 1. What is the? It is a symmetric about the x axis and y axis. Here you can take the along x axis, along the y axis symmetricity. Based on that you can identify the areas. But 2 methods we can be used. Hence here it means that it is a conversion into the dy and conversion into the dx. Now we know that ellipse is a symmetric about the x axis and y axis, so that here area ellipse is area of the region, I am bounded area, I am identifying into the figure 6. What is that? OAB. First OABA, that is the 4 times of area of the first region curve. Within the interval, what is the interval? You should check 0 to A, x axis if I take, y axis if I take 0 to B, function in conversion of the y, f of y if I take dy, we will take the interval is a 0 to B. Now here x, y values if we substitute x is converted, then interval is goes to the 0 to A. Now coming to that, here 4 times of area of the first region AOBA of in the first quadrant of the bounded by the region curve, given curve coordinates are the 0 to A area along the x axis. Now total ellipse is the area is a AB A B dash A, total rounding of that area, that is I am converting into the 4 times of single quadrant area, first quadrant area. So that it is I want to convert into the dx form, dx in terms of x. So that equal to 4 times of integral 0 to y dx, because of coordinates is x axis is I have taken 0 to A. Now this is a vertical steps, taking the vertical steps. Now since x square by a square plus y square by b square equal to 1, we can take y square by b square equal to 1 minus x square by a square. Here y equal to plus or minus b by a into root of a square minus x square. So y equal to b by a root of a square minus x square. The function is a modulus if I take b by a into root of a square minus x square, because of first quadrant. So region AOBA lies in the first quadrant, y is be taken into the positive. So here integration, right side here the figure beside I am taking the area finding is the vertical steps. So it is equal to the 4 times of integral 0 to A b by a into root of a square minus x square dx. What is that? It is a y value, functional value, y equal to b by a into root of a square minus x square. Here I am taking the positive only, plus or minus, but not negative, it is only the positive, because of it is a positive, first quadrant is a positive. So 4 times of integral 0 to a b by a root of a square minus x square dx, this is a simplification. Now I am finding equal to 4 by b by a. It is the root of a square minus x square, integration is a x by 2 root of a square minus x square plus a square by 2 into sine inverse of x by a 0 to a. So that is a formula for root of a square minus x square. What is the formula? X by 2 into root of a square minus x square plus integration of root of a square minus x square. I am substituting direct formula, x by 2 into root of a square minus x square plus a square by 2 into sine inverse of x by a. In the interval 0 to a, integration over, so that interval I am substituting 0 to a, lower interval 0, upper interval a, because of x coordinates is a distance is a 0 to a only. Now 4 by b into a, upper interval I am substituting, first term becomes 0 and sine inverse a by a 1. So sine inverse 1 I got it, minus here lower interval substitution 0, 0 by 2 into something 0 and sine inverse is 0 also 0, so that second term also 0. So 4b by a, it is a square by 2 into sine inverse 1, sine inverse 1 is a pi by 2. So in this denominator 4 and numerator 4 cancel, and numerator 1a and denominator a cancel, so pi ab, this is a total area of the ellipse, total area of the ellipse. This is a clearly vertical steps. If I take into the horizontal step, 4 times of integral 0 to b x dy, So 4 times of a by b into 0 to b root of b square minus y square dx, because of I am taking the horizontal. Now 4a by b into y by 2, this is the root of b square minus y square integration, y by 2 into root of b square minus y square plus b square by 2 into sin inverse of y by b, 0 to b. Same upper interval substitution. Here b square minus b square is 0, b square by 2 into sin inverse b by b, sin inverse 1, minus lower interval y is a 0, so that 0 first term, second term also sin inverse 0 by something 0. So totally it is a b square by 2 into sin inverse 1 is a pi by 2, 4a by b. Here denominator 4, numerator 4 cancel, bb also cancel, denominator b, numerator b, next pi a b. So answer is the same while using the horizontal step and vertical step for enclosed by the closed curve. This is a ellipse is a closed curve, enclosed by the closed curve. Now I am going for that is the next example. Here find that is the area under the curve f of x equal to cos x in 0 to 2 pi. Here cos x is take the positive in the interval between 0 to pi by 2 and union 3 pi by 2, 2 pi. So whenever the cos x is less than or equal to 0, means it is a function is comes to the here pi by 2 comma 3 pi by 2. So there it is a total 0 to 2 pi. The areas are divided into the 3 parts. One is 0 to pi by 2 is a positive, cos x greater than or equal to 0. Pi by 2 to 3 pi by 2 is the less than, bottom side, and 3 pi by 2 to 2 pi is the top side. Then I will go for that is a area. First upper side area plus middle lower downside area plus upper side area. It is a because of it is a cos x is a participated in the intervals between the 2 pi is a 3 bifurcations of intervals. One is the 2 are the positives, one is negative. First part is a positive and last part is a positive, and the middle part is a negative function. So that it is a area with pi by 2 to 3 pi by 2 is a negative, so that it is a I will take into the bottom. That figure in the figure we can see clearly. Now here 0 to pi by 2 it is upper side cos x into dx plus pi by 2 to 3 pi by 2 minus cos x dx plus 3 pi by 2 to 2 pi cos x dx. Now it is a equal to, here I will take that it is a cos x integration is a sin x 0 to pi by 2, here minus cos x is a integration is a sin x, so pi by 2 to 3 pi by 2, here my inside is a minus will be there in the middle term, so that take the common plus into minus minus. So here cos x integration is a sin x pi by 2 to 3 pi by 2 plus cos x integration is a sin x, here 3 pi by 2 to 2 pi. Now first part is the upper interval, here the sin pi by 2 is 1 minus sin 0 is a 0 minus plus second term it is a sin x sin 3 pi by 2 and minus it is a sin pi by 2. What happened? It is clearly plus 2 minus 2 minus or minus plus 2, last term sin 2 pi minus sin 3 pi by 2. So it is plus 1, total area is a 4. So area is under the curve, it is f of x equal to cos x in 0 to 2 pi. What it is that it is clearly it is the first part is a simple closed curves, like that it is a bot up and downs. Up side is a function is f of x greater than or equal to 0, bottom side is f of x less than or equal to 0, upper side f of x is greater than or equal to 0. And enclosed means it is I used the ellipse example. This is a finding of the areas for the first part. Next second concept is comes to the area of the region bounded by the curve and line. What happens? It is a I am taking the for example it is a y equal to x square parabola I am taking. Now it is a parallel to x axis, y equal to 4 equation he has given. Now he is asking that find the area of the region bounded by the line y equal to 4 and the parabola y equal to x square. Y equal to x square symmetric about the y axis, parabola y equal to x square I am taking. Now it is a up direction, upwards. Then it is a bounded area is a we don't know. So bounded area purpose he gave the line is a y equal to 4. It is a x axis symmetric to the along x axis, so that y equal to 4. It is cutted to that AB. So here areas are occupies A, O, B, N. AON is a one area and NOB is a another area. So one area if we identify, another area also similar because of it is the same area will occupy. Now it is a AOBA is a total area of the region for the given curve parabola symmetric about the y axis and bounded and touches to the line y equal to 4. That is a figure clearly we can identify. Now area A equal to 2 times of here 0 to y equal to 4 x axis, it is a y axis is interval is how much 0 to 4. So y axis, so that I am taking into the dy term. So 2 times of integral to y, because of 2 times it is a AON and NOB, both are the same. So that 2 times of one area I am finding, it is a NOB I am calculating area, so that it is a totally dy terms I want to convert. So function is a here y equal to x square. So it is along x axis, so that it is a x dy. Y equal to x square, I want x equal to plus or minus root y. Here positive direction, so only I will take plus root y. So here x equal to plus root y into dy. Here interval is a 0 to 4. Why? Because of 0 to 4. Here y axis at last edge touches to end point is a 4 distance. Origin is a 0, y distance is goes to the 4. So coordinates are y equal to 0, y equal to 4. Y interval are 0 to 4. Now here 0 to 4, x dy, x equal to how much? Y equal to x square. It is x equal to plus or minus root y, only it is a positive direction. So plus root y into dy. So 2 times of y to the power of 1 by 2. Y to the power of 1 by 2 integration is how much? Y to the power of 1 by 2 plus 1 by 1 by 2 plus 1. So y to the power of 3 by 2 by 3 by 2. So denominator 3 by 2 will be goes to the numerator is a 2 by 3 into y to the power of 3 by 2. Here 0 to 4 if I substitute 4 to the power of 3 by 2 minus 0 to the power of 3 by 2. Total simplification is a 32 by 3. That is a total area. It is a region bounded by the curve, parabola and line y equal to 4. So it is a region bounded by the curve, line, curve and line. At the time we use this procedure. Next, sir, it is a you are taking along the x axis y interval only. Why don't I take the x interval? Yes, you can take, because of here y equal to 4 you substitute. What happens? 4 equal to x square. At the time x equal to how much? Plus or minus root 4. So x equal to plus or minus root 4. So x equal to plus 2 and minus 2. So area is a plus 2 to minus 2, minus 2 to plus 2. It is a vertical strip. Previously it is a horizontal strip I used. Now here function integral minus 2 to plus 2 f of x dx. Previously I did dy, now I want to convert into the dx. What about y equal to x square? So y equal to x square. Here I am finding that is a area of the coordinates of the function b minus y, so that it is a equal to 4 minus x square. Why? Because of x square equal to y value is a 4. One side if we take 4 minus x square is a function. So that y, it is a function y is equal to 4 minus x square. Directly I will substitute. So y dx 4 minus x square into dx 0 to 2. So 2 times of integral 0 to 2 4 minus x square into dx. Here 4 integration if I take 4x minus x square integration x cube by 3 0 to 2. Here 2 times of it is a, sir, why it is a 2 times? It is a minus 2 to 2. It is a here also vertical strip also, here two partitions, 2 times of 0 to 2 I have to take that instead of minus 2 to 2, 2 times of 0 to 2 I can take, so that it is a 0 to 2, lower interval 0, upper interval 2, I will take the integration. Here 4 times of 2 minus 2 cube by 8, lower interval is a 0, 4 into 0 minus 0 cube by 3 0, so that no need to take. Here upper interval only here exists 2 times of 4 into 2 minus 2 cube by 3, so that simplification is a 32 by 3. What is that? It is a previously answer is 32 by 3, it is along the y axis, it is along the x axis. So here strips are the, one is horizontal, one is a vertical strips. So that same answers we can be get it here for this concept of area of the region bounded by the curve and line. Next, another example, find the area enclosed by the enclosed between the line y equal to x and y equal to x cube. Previously y equal to x square I did. Now I am going to do the y equal to x cube. What happens? It is a point, it is a line is a y equal to x. So it is a here in between that is a x and y. It is a middle pass first quadrant to third quadrant line we can be having, so that y equal to x line I will take. Next it is a y equal to x cube. What happens? It is also here touches to the origin and bending to the third quadrant to the first quadrant, so that we can be see in the figure clearly. That is a y equal to x cube curve. Now bounded region is enclosed region is comes to the here what is the dark line into the first quadrant as well as third quadrant. Now here points I want here y equal to x and y equal to x cube. So y equal to x and y equal to x cube, I will take x cube equal to y equal to x, so that x cube equal to x. Here common, if I take x equal to x square minus 1 equal to 0, their points are x equal to 0, minus 1 and 1. Here 1 and 2 intersecting points, here y equal to x and y equal to x cube intersecting points are 0, 0 as well as 1 comma 1. Why? Because of here x value 0, minus 1, 1 and y equal to x, so that y also same quadrant of x, so that 0, 0, minus 1 and 1 comma 1. So here we can identify that in the figure minus 1, 1 minus 1 and 1, 1 in the first quadrant, minus 1 minus 1 is the third quadrant, origin is the intersecting point 0 to 0, 0 comma 0. Now it is a regions wise, if I observe that A1 equal to area of the region R1, that equal to integral 0 to 1. So here 0 to 1 I am finding, first quadrant area I am finding 0 to 1. What is the function I am substituting here? Here x equal to y equal to x cube, so that it is x plus y, x minus y equal to x, so that x minus x cube into dx. Integration, if I take x square by 2 minus x to the power 4 by 4, 0 to 1. So upper interval substitution 1 by 2 minus 1 by 4, that answer is 1 by 4, that is the area of the region 1. Next we go for the area of the region 2, it is a minus 1 to 0. What is that? It is the third quadrant, minus 1 to 0. So it is the occupied area. Now here R2 equal to integral minus 1 to 0 x cube minus x into dx. Now integration x cube by x cube integration x to the power 4 by 4 minus x square by 2 minus 1 to 0, that equal to 1 by 4. The required area equal to first area and first region 1 area and region 2 area, A1 plus A2. So 1 by 4 plus 1 by 4, total is equal to how much? 1 by 2. So this is a region 1 first quadrant area and third quadrant area is a region 2, so that 1 by 4 plus 1 by 4 equal to 1 by 2. Last concept is the area enclosed between the two given curves. Here y equal to sin x and y equal to cos x between the consequences points of intersecting, if I take, what happens? It is a area enclosed between the two given curves, y equal to sin x and y equal to cos x, so that here x equal to pi by 2 and x equal to pi by 4. So here sin x is greater than or equal to cos x. So bounded between that is area x equal to pi by 2 and x equal to pi by 4. So that here figure we can see that here pi by 4 to pi by 4 in between there. Here sin x curve is a up, top it is a top down, and it is a starting point is a 0, and it is a cos x function is a starting point is 1, so that it comes to the down. It is a bounded region is a here shaded region, that area we want to be identify. Here such cases A equal to pi by 2 to pi by 4. Here upper area minus lower area, sin x minus cos x into dx. So sin x integration minus cos x is a sin x. So cos x is a sin x, so that it is a pi by 4 to pi by 4. It is substitution is a root 2 plus root 2 equal to 2 root 2. Now it is another example, also the same, it is a bounded area, we can see in the area. Now here same procedure if we apply. Next summary of this topic is first region of the curve, it is a simple curve. If I identify y equal to f of x, directly area equal to a to b into f of x dx whenever the function is greater than or equal to 0, that we identified. And whenever the function is less than or equal to 0, minus integral a to b f of x dx we can be get it, but here we should take the mod value, that is whenever it is a function is in the lower. That is the first point is a summary that we identified, and I have given the example. Next second area, it is whenever there is a region bounded by the curves, two functions x equal to f of I and x equal to g of I. Now here it is whichever is the highest, it is a function is greater than or equal to 0, that is f of I minus g of I within the interval c to d, that is a last concept, it is a function. Next it is a given region enclosed between the curves y equal to f of x and y equal to g of x and x equal to a and x equal to b, given a region a equal to now f of x minus g of x whenever the function is f of x is greater than or equal to g of x, interval a to b. Now, f of x is greater than or equal to g of x in the a to c interval, it is a, if I take that f of x is less than or equal to g of x, it is the functions are in between, it is partitions we have. One function f of x is greater than or equal to g of x in the interval between a to c and a to b, in between one point is there c. So, that f of x is less than or equal to g of x, interval between c to b. So, a to c interval is the function f of x greater than or equal to g of x, and c to b interval is a f of x is less than or equal to g of x. In between we can use that here area equal to integral a to b, a to c, first function f of x is a bigger one. So, that f of x minus g of x into dx plus c to d, c to b, here bigger one is a g of x because of f of x is less than or equal to g of x. So, interval between c to b. So, c to b, it is a region 2, it is a g of x minus f of x into dx. Both the regions we identify, that is a A1 region plus A2 region, that is called as a total area. This is a overall idea about it, our total summary of the integral. By using the integrals we can identify the area. Queries, and thank you all.